This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 3, Lesson 4, Constant and Variable Scope. A constant or variable that is defined outside of a function has global scope. For example, here global variable has global scope, and so you can access global variable anywhere in your program. A constant or variable which is defined within a set of braces has local scope. That variable can only be accessed from within that set of braces and after it is defined. So for example, here we define a new constant local variable. It is of type integer, and it is only accessible from this line where it is defined till the end of the braces in which it's defined. So after this brace, you can no longer access local variable. Here we create a global variable age. It's available everywhere. We also define a function. Then, as we continue execution of our program, we print age, and we can access age because it is a global variable. And then we execute the function printMyAge. And from within printMyAge, we can still access the variable age because it's a global variable. Here we have a function, and then we execute the function. And when we execute the function, we create a new local variable called bottle count. And we can access bottle count and use it within this scope between when it is created and the braces at which closes out that scope. However, once we return from the function, if we attempt to print bottle count again, we are out of scope for the local variable bottle count, which means the variable no longer exists, or at least we cannot access it with this identifier, and as a result, the compiler throws an error. Here we use a for loop to iterate from 1 through 10 inclusive. And for each iteration, we create a constant index. And the scope for index ranges from this new brace to this closing brace. And so within that set of braces, so within the for loop, we can use index. However, if we attempt to use the identifier index after we finish the for loop and after the closing brace, then we're out of scope for index and we can no longer access it, which results in a compiler error. Meanwhile, name, which was a local variable created in our function, we are not out of scope for that variable because that variable scope ends at this lower brace down here. So name would work, but index would not. Here we define a global variable points, and then we have a for index in 1 through 3, so our for loop, where we have a local variable also named points. And then in our loop, we are using the points variable. The question is, which points variable do we use? Do we use the local one or do we use the global one? And the answer is we use the one with the closest scope. So we can see that here where we print out the values of the loops, and the first loop it's 201. So obviously points 200 is being used and points 100 is not. And so we execute the loop 3 times, print out 201, 202, and 203. Then we get down to this point. We use points, and which points would we use? Well, this one here that was declared inside the for loop is now out of scope because we are after the closing brace. As a result, the only points that is still in scope is the global one. So down here, we print out 100 for the global scope points. This is called variable shadowing. Be careful when you use variable shadowing. When you're looking at the code and you see this points, it may not be clear to a reader whether you are using this points or this points. And that kind of confusion can cause programmers to program bugs. We can combine variable shadowing with unwrapping optionals for our benefit. In this case, we have name, which is an optional string. And then we use the if-let syntax to unwrap the optional, conditionally unwrap the optional into a non-optional. When we do that, some programmers like to use the same identifier for the non-optional as the optional. And then for this print statement, my name is name, well, which name is this one referring to? Is it referring to this name here, which is local scope, or is it referring to the global scope? And the answer again is the name will always refer to the one that has the closest scope. So instead of using the optional name, this name here, we'll use the non-optional name that we unwrapped. Here are two more examples of using variable shadowing with optional unwrapping. In the first one, we have a function which has a name parameter, which is an optional string. And then we use the if-let syntax to unwrap the optional name into a non-optional name. And then within the if block, assuming a successful unwrapping, we can access the non-optional name and use it. In this case, the non-optional name will shadow the optional name because the non-optional name, the unwrapped name, has a more local scope. This also applies for the guard let statement. Here we have another implementation where we pass it an optional string called name, and then we use guard let syntax to unwrap the optional name into a non-optional name. And then after the guard statement, this non-optional name will remain in scope until the end of the next brace. So we can access it and print out the name. The member-wise initializer of a struct uses argument names that are the same as the property names. That makes for readable code because the argument names are also used as property accessors. So we can print Todd.name and it works. Here's what the initializer looks like. We have the name as a parameter and we have the age as a parameter. And the problem is we also want to access our name property and our age property. We have to take the name parameter and copy it to the struct property. And the way we do that is we use self.name. So this name refers to the constant with more local scope, which is the parameter of the initializer. But to access the property of the struct, we can't just use name again because that would be ambiguous. Instead, we have to use self.name. And so we have a new keyword self, which refers to the object or instance that you are in. So we can take the name parameter and assign it to self.name, which is the struct property. If you are following the Apple curriculum, now you can go open up the scope.playground and complete the lab. This slide deck was created by Apple and is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.